Hello friends, welcome back. In the previous video, we talked about the differential equation, right? First, we studied what is a dependent variable, and then we studied what is an independent variable. And the rate of change with respect to the independent variable in the dependent variable is called the derivative, right? And if we again applied the rate of change in the first order derivative term, then we will get in the second order differential term. And again, if we apply the rate of change with respect to the independent variable in the second order differential term, then we will get the third order differential term, right? Then what we have seen a nth order differential equation with the non-homogeneous term, right? And I definitely told you about the thing, that is the why it is called the non-homogeneous differential equation, because the left hand side is having the dependent variable and its derivatives, and the right hand side having a function of independent variable, right? Now we were at the point solution of differential equation. So the solution of equation 1 was given by yx equal to complementary function plus particular integration, right? Now our target is to find out the complementary function, so we will go through the complementary function first. Okay, so now we will go the complementary function. Complementary function. So what is a complementary function? Right. In order to find out the complementary function, first we have to do what? We have to write a homogeneous differential equation. First we have to write a homogeneous differential equation. The first step, write homogeneous differential equation. So how can we write the homogeneous differential equation? We can write it by, suppose we are having a second order differential equation, d2y upon dx2 plus p dy upon dx plus q y, that is equal to fx. This is non-homogeneous, right? But if we want to write the homogeneous differential equation, then what we have to do? We have to put this fx equal to 0, right? So if we put this fx equal to 0, then we will have the equation d2y upon dx2 plus p dy upon dx plus q y, that is equal to 0. This is called homogeneous differential equation, right? So it should be remembered, if we have to convert a differential equation into a homogeneous differential equation, then we will put the non-homogeneous part, that is a function of x, completely equal to 0. So this equation is our homogeneous differential equation. Now the solution of this homogeneous differential equation is called the complementary function. Okay, so I will write this line, the solution of, if you call it the equation number 2 of 2 is called complementary function, that is our CF, right? So if we are clear about the idea of complementary function, next we will go for the methodologies by which we can find out the complementary functions. Okay, so in order to find out the complementary function, first what we have to do? First we have to find the auxiliary equation. The first thing that we have to find out the auxiliary equation. The auxiliary equation. So in order to find out the auxiliary equation, if we call this equation as 2a, then replace d2 dt2 or dx2, pardon, dx2 by capital D2, right? And then d upon dt by capital D. Okay, so what we will have in equation 2? We will have in equation number 2 or 2a, but we are finding out the auxiliary equation, then we will go through the equation number 2. So then what we will have? We will have d2 y plus p dy plus qy, that is equal to 0, right? Separate the operator form and the dependent variable. d2 plus pd plus q y, that is equal to 0. Here what we did? We just separated the operator form and the dependent variable. This is not called the common. Most of the professors or most of the students know that we have common y from this particular expression, but in real this is not so. This is not the commoning, this is the separation of the derivative term, and means the operator term and the dependent variable. Now we will move forward. What we have to do? We have to replace d by m. Okay, so we will have m2 plus pd plus q equal to 0, and that is the auxiliary equation. And here is IARY, auxiliary equation, right? So this is the auxiliary equation, and here I have missed I also, right? So this is called the auxiliary equation. Now find out the roots of this auxiliary equation, and then we can write the solution. Find the roots of auxiliary equation and get the desired solution. So this is it from my side in today's lecture, because in this lecture we have covered the topic how can we find out the auxiliary equation. In the next lecture we will cover the topic how can the auxiliary equation give the solution of the homogeneous differential equation. For now, goodbye. Please be happy and keep everyone happy.